Today's experiment, we will cover the naming of organic compounds. We'll start first with the courses naming organic compounds. First, we'll go through the alkanes, the hydrocarbons, alkanes, alkenes, alkynes. So the alkanes is straightforward. So what we are doing is we are looking at the longest chain and we number the number of carbons and then number them and then add the ending will be ANE. So we'll do the number of carbons plus ending ANE. For example, if I have now, this is so number of carbons are 1, 2, 3, 4. 4 number of carbons. That will be 4 is bute. And then we'll add to it ANE. That's a butane. Maybe it will be nice if we know how we'll looking at them to number those carbons. So so if I have a carbon is 1, so that's a meth. That's a meth. If it's functional group, will be methyl. YL, we add YL. Carbon 2 will be F. Carbon 3 is prop. Carbon 4 is bute. Carbon 5 is pent. Carbon 6 is hex. Hex. Carbon 7 is hept. We'll take up to 10. Carbon 8 is oct. Carbon 9 is known. Carbon 10 is dec. So as you can see, it goes by the number of carbons, and in the previous example, we have 4 carbons. That's bute. Since it's an alkane, we add ANE. ANE, so that's butane. Now let's look if we have an alkane. That will set an example for alkenes with the double bonds and alkynes with the triple bond. So if we have, for example, the alkenes, if we have an example of alkanes, not alkenes yet, a single bond, all those alkanes are single bonded with ANE at the ending. So look at some of the functional group attached to the main chain. Let's look at this. Suppose I have now, say CH3, CH2, 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 CH, CH2 and CH3 at the end. So 1, 2, 3, 4, 5. And we want to put some we'll attach some groups inside. So suppose in this here position here, we will add we'll add a group here. We'll add BR, and in this group here, CH2, we'll add Cl. Okay, and in this group here, we'll add CH3, and that will set this the same examples for the alkenes with the double bond and alkynes. So if we got those alkanes, straighten up their names, so with the all single bonds, the double bonds E and E, or the alkynes with the triple bond will follow the same thing except for the ending. So alkanes ending A and E, that means single bonded hydrocarbons. So here it's, since now it's attached, it will be called methyl. This is methyl. One carbon is meth. When you attach it as a group, it will be methyl. This is attached, bromine atom will be bromo. And this is attached here, will be chloro. So this name of this compound, first you name the longest chain, correct? So we can start from left to right, or we can start from right to left. Well, it turns out to be the M. We are looking for the M and the beginning of those functional group, and the C. The C is the winner because the C comes before the M. So we'll start our numbering will start 1. Sorry here. 1, 2, 3, 4, and 5. So we have 5. This is spent. 5 is carbon 5 spent, and then end single bonded pentane. The ending is ANE. Now, looking at this from this perspective, we'll start with the numbering of the functional group. So I have here 1 chloro, and then 3 bromo, and 4 let's take the pentane out, 4 methyl pentane, ANE. So that's how we name the alkanes. So straight chain, and we always looking at the functional groups attached to the main chain, and the least alphabets. I mean, not the least alphabet, means in the series of the alphabets will win, and then we'll number the chain as such. So the C, the chloro, will come before the methyl M. So that's an example here. Let's look at the number 2. Number 2, let's look at the alkenes. Well, alkenes is the same rules like alkenes here, but we have to end ENE at the end. That designate the double bond. And it's very important to know the number of carbon atoms which establish the whole long chain. And you have to locate the number, the double bond. The location of double bond has to be designated by a number. So suppose I have something like this, CH3, CH, then CH, CH3. So I can go left or right. Let's add more. Let's add more carbon. So let's add more carbon so we get the idea here. CH2, CH3. Now always we try to have the location of the double bond to be the least numbering. So if we start from left to right, then the number of the double bond will be this number will be 2. If we start from right to left, then the numbering will be 1, 2, 3. So the numbering will be 3. So the rule says that it has the double bond as well the triple bond has always the least numbering. So the 2 will win over the 3. So therefore, the left to the right is the correct numbering. So we'll number this as 1, 2, 3, 4, and 5. So this is a bentene. So this is bentene. Bent means 5. And then because we have a double bond, E-N-E, bentene, one word. So let me just put it as one word so don't come to the idea there's two separated words or no. Bent, E-N-E, bentene. Now we have to designate the number of the double, the location of the double bond. So the double bond is located at number 2. So 2 bentene. So this is 2 bentene. So that's the whole thing. And you can add to this, some functional group. Those functional group can be methyl, ethyl, chloro, bromo, whatever, but it will be following the same rules of the alkanes. However, here the location of the double bond will take first priority, not the chloro or the fluoro. So let's do an example here and then say, okay, let's see what we have to do. So we know that's 2 bentane, correct? So let's take this 2 bentane out and say, okay, that's 2 bentane. We know that this is 2 bentane. Suppose now we are having some attached group, and those attached group here is say methyl, and this attached group is say ethyl, and this one here will be chlorine. So this here 3 has to be 2. So now, regardless of the functional groups attached to the main chain, the double bond will take first priority. So still it is 2 bentene. 2 bentene. The double bond is located at carbon 2. But we have to do this is chloro. This is ethyl. This is methyl. And we know the numbering of those carbon chain is controlled by the location of the double bond. The same thing with the triple bond. So that will be then the C will come before the E before the methyl M. C before the E before the M. So it will be one. This is 5. Sorry, 5. This is so. Let's write the name here. Maybe another color so you can follow. So this will be the C will come before, so that's 5 chloro, 4 ethyl, and then you have 5 chloro, 4 ethyl, and then 1 methyl, and the whole thing that's before come before, and here from this will be 2 pentene. So that's about alkenes. Let's go for alkynes. Alkynes will follow the same thing. I mean, it's just the location of the triple bond and the number of the carbons. And when it comes to functional group attached to this main chain, always goes by the alphabets. But the triple bond, the same thing like the double bond, will be the most important part of the numbering of the long chain. So let's do the alkynes. Alkynes with the triple bond, suppose you have CH3, C, triple bond C, CH2, CH2, CH3. This is CH2. So how many carbons we have? We have 1, 2, 3, 4, 5, 6. 6. So that is hex. And since it has a triple bond, YNE at the end, so the ending is hexine. Where is the triple bond? The triple bond can be from the left to the right. It will be from left to the right. The double bond will be number 2. Or it will be from right to left. 1, 2, 3 will be 4. So the 2 will win. That's the least one. So it will be 2 hexine. Now we can attach group will be the same thing we did the double bonds. And you can follow the same thing we did with the double bonds. You can attach group, any functional group, but then you have to look at their alphabets. Now, the location of the double bond and with the least numbering, that will control the numbering. Then whatever the attachment will be controlled by their first alphabets. Chloro would be C, methyl will be M, ethyl will be E, and so on. And that's an example here. So that's about those 3 major hydrocarbons. Now in the hydrocarbons, we have cyclic as well as aromatic. So let's take this one out and look at the cyclic and aromatic. So we'll do aromatic hydrocarbons. The aromatic hydrocarbons. The aromatic hydrocarbons, they have to have a benzene ring. A benzene ring has 3 alternating double bonds. Those are not localized, they are moving around. They are moving around, and now is, so therefore, well, because of they are moving around, we give them a loop. So that's designate this, those triple bonds are moving around. So this is benzene, okay? Benzene. Now it's attached, if it's attached to a chain, it will be phenyl when it's attached to a main chain. When it's attached, called phenyl. So depending on whatever you have there, correct? Suppose we have here one methyl group. So that would be methyl benzene, correct? And this methyl benzene has a specific name, IUPAC name. Methyl benzene is correct, but it has called, this one here, called toluene. So toluene, Toloune, toluene. Now, with this one here, we can add to this another methyl group. So we can have another methyl group here. Let's take this one out. Take all those out, and we can add to this another methyl group here, for example, and another methyl here. So the two methyls, let's add this one, number them 2, 3, 4, 5, 6. So the benzene has 6 carbons and 3 double bonds. So we can call this one here is 1,4-dimethyl, because 2 methyls, benzene. Now this one here, according to IUPAC, it has a name called, like the toluene with one group. This one called xylene. Toluene, this one called xylene. But 1,4-dimethylbenzene is correct. That's absolutely correct. And methyl benzene is correct. But the IUPAC name said this is a toluene, because when you have an attachment, then it will be very long, the name. That's the reason you get toluene, one methyl group, and the methyl 1,4 is called 1,4-dimethylbenzene or xylene. Now, because this is 1 to 4, they're opposite to each other, we can call them para. Para means opposite to each other. So this is called para-xylene or para 1,4-dimethylbenzene. Now, if we have a 1,4, we can have 1,2 and 1,3, correct? So let's look at this. Now I can have xylene or dimethyl 1,4. We did that's 1,4 called para. Now how about 1, 2, 3? 1, 3. This is nothing there. Those are not attached to anything. So here it is. So this is 1,3-dimethyl benzene. 1,3 called meta M, like the one para with P, para opposite each other, meta benzene or meta xylene. This is M-methazylene, 1,3. Now, if we have 1,2, then we'll have ortho. So we have what? We have ortho. So let's take this one out and look at the benzene here. This is 1 and 1, CH3, CH3, 1 and 2, 1 and 2, dimethyl benzene, called ortho. O stand for ortho. So ortho, the attachment of the methyl group in 2. So this is orthoxylene. Okay, guys, so we have para, P. Para means opposite to each other, which is the location 1, 4. And meta is 1, 3. And ortho is 1, 2, the location of the methyl group. So that's about the aromatic, which is very important. Now you can attach any other group to it, but then you have to look at the numbering. The numbering has to yield a smaller numbering, not large numbering, correct? So it has to yield lower. So if I have here, for example, chlorine here, will be, this is the whole thing is orthoxylene, correct? Octoxylene, xylene. But then you have number 6, 2, 3, 4, 5, 6 will be 6. Let me just take this one out. So I have here chlorine here. I'm sorry. 1, 3, 1, 3, 1, 4. So you have chlorine here. So it will be 6 chloro, and then this is orthoxylene. Okay, guys, so that's aromatic. Let's go for the cyclic. The cyclic is different from the aromatic because we don't have the triple bonds around, the triple bonds, 3 double bonds. The triple bonds mean 3 double bonds around the ring. So we can start with something looking like this, something looking like this, something looking like this, something looking like this. There are there is no double bonds there. So when we have something like this, always you'll start with the word cyclo, and then you number those numbers 1, 2, 3. So cyclo, and this is alkane, there's no double bond, cyclopentane. This is cyclobutane. This is 5 carbons, cyclobentane. This is 6, will be cyclo, always the cyclo means the ring, cyclohexane, hex, A-N-E. Now, sometimes with this cyclic ring, you might get double bond. That's not a problem. And you might get substituents. That's not a big problem. That's not a big problem. So we can give you just an example here of this one here. Let's take this out. Let's stay on the one of them. Let's take the butane. That's the same thing will be standing for both. So let's have we have a double bond here, and we have substituent here, chlorine, and here is methyl. So this is chloro with the C. This is methyl with M. So the whole body is a double bond, it's a cyclic, so cyclo. Since we have a double bond, the double bond will control everything. So the numbering will start here. Okay, then you have to close the double bond. It can't be the two here. It has to be the two here. You have to close what? The double bond. 1, 2, 3, 4. So you have 1, the cyclobutene. That's a double bond there at number 1. Then you have the chloro will come, the C will come before M. Then you have here 4 chloro, and then 3 methyl, 1 cyclobutane. That's about the cyclic. Now, let's go and look at the alcohols. Look at what the alcohols. So how we name those alcohols. So let's take this one out and look at the alcohols. Well, it turns out to be alcohols. Alcohols is derivatives of H2O. If you look at H2O here, replace one hydrogen with the R. Okay, it's organic group. So you get the alcohol. So the R, for example, can be anything. Stick the R here and add methyl. So the common name is methyl alcohol, correct? But that's not the IUPAC naming. The IUPAC name will tell you you get this here from the alkane. This is methyl, this is methane. Take the E out and add OL instead. So this is methanol, correct? This is what? This is methanol. So the same thing, if you can go and make another example. We can make an even longer one. And we can take CH3, CH2, 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 and OH. So now that's a long chain, correct? There is no branching, there is nothing like this. 1, 2, 3, 4. That's a butane, correct? Take the E out, add OL. So this is butanol. This is called what? Butanol. Now the OH, the alcohol, we have, that's this one here called primary alcohol. Primary alcohol. And is designated with the 1 and then degree on this alcohol. Now, if we have a primary, we have to have secondary and we have to have tertiary. So what's happened is the tertiary alcohol, we are not naming just this type of alcohol, but this is what that really is. So suppose now we decided to make a tertiary one, and a tertiary one, so we have to, we'll take this one out, correct? We are making tertiary now, so let's see. So what is tertiary alcohol? Well, it turns out to be, let's look at this. This is CH3, and the OH is here now. not in this location. It looks like the tertiary alcohol is an alcohol that carries out the carbon that carries out the OH group carries at the same time how many groups? Two groups. That's we call it tertiary. We call it what? Yeah, secondary, not tertiary, sorry, secondary. This is the secondary, correct? This is what? This is secondary. So in order to name this according to the IUPAC name, the long chain, you go for the name of long chain, 1, 2, 3, 4, 5. This is what? 5, correct? This is 5. Oops, sorry. 5 means bent, correct? So this is pentane, take the E out, OL, that's pentanol. Now the hydroxy group is number 2, so 2-pentanol, and this called secondary alcohol, correct? Now, the tertiary alcohol, on the other hand, the group that carries out the OH will have 3 groups. So here it is. Let's take this one here out. We are making tertiary alcohol now. So this is OH. And we'll take the OH here out too. We'll take the OH out here too. And we'll have the group that carries out the OH will have, this is another group of methyl group. So the group that carries out the OH is attached to 3 groups, 2 methyl groups and 1 ethyl group. So this one here, it goes out by what? It goes out by the long chain. The long chain is 1, 2, 3, 4, 5. So if you look at the long chain, 1, 2, 3, 4, 5. So this is pentanol, pentane and then all, pentanol. And where is the OH? Number 2. Always the numbering has to yield the least one. We are doing the least one. The numbering will be from right to left. That's 2. Okay, not 4. 2 pentanol. Now in the number 2, because the numbering should be so here it is. This is 3, 2, CH3. So the numbering will be 1, 2, 3, 4, and 5. So will be number 2, 2-methyl, 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 2-pentanol, 2-methyl, 2-pentanol. So that's called tertiary alcohol. Why is tertiary? Because the carbon that carries OH carries 3 groups. This is the carbon that carries the OH, carries 3 groups. 2-methyl group and 1 ethyl group. 2-methyl group and 2 ethyl group. So that's alcohol. Let's go for closer to alcohol is ethers. And ethers is very unique in the sense you have always 2 groups connected to oxygen. It's similar to OH and similar to alcohol, but the alcohol here is connected to among themselves through oxygen. So here it is. I have CH3, CH2, CH2, O, CH3. Okay, guys? So if you have something like this, then you look at the long chain. The long chain is here between the two, and here the smallest one. So then it will be 1, 2, 3, correct? So that will be pentane. So alkane will be here. And then you name the whole group here with the oxygen and this group here, methoxy, methoxy, methoxy pentane. Not pentane, sorry, propane, sorry, I apologize. Methoxy propane, that's a propane. I apologize. So, okay, guys, so you look at the long chain, you give the name, that's the long chain, 3 carbons. This is a small chain, 1 carbon. So the 1 carbon then will have methoxy, ethoxy, and so on. So the smallest one. We can take another example of this and say, okay, let's have CH3, CH2, and then O, CH2, 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 CH3. Now, what is the longest chain? Here is 2 carbons. And here we have 1, 2, 3, 4, 5. 5 carbons. So the longest chain is 5. So that will be is pentane. Correct? That's the longest chain. And this one here, remember there's an oxy. And then this is an ethyl group, ethoxy. So not ethyl, ethoxy, methoxy. Not ethyl oxy, methoxy, ethoxy, pentane. Okay, guys? Now we'll go and name the aromatic alcohol. We just skip that because we want to always relate the alcohols with ethers. So let's go and look at the phenols. What are those phenols? Well, it turns out to be a combination of benzene ring, okay, with the OH. So we can call them hydroxy benzene. And the name of it is, adopted by RBC, is a phenol. Now they can have attachment. That's always in the phenol. That will be, this carbon will be given the number 1. And then you have here, for example, chlorine. Here is bromine. And here is methyl group. Now, you can number from the ring of the benzene from left to right cycle, or from right to left. Now, if you look at this, well, I will say if I go like this, goes by the alphabets, will controlled by the alphabet. The numbering, the number 1 we know, but the numbering will come through the alphabets. Here we have B, here we have C, and here M, methyl. So the bromo will win. So 2, 3. So the bromo will be given priority over the C, over the chloro. This is 4, 5, and 6. So how we number this? The whole thing is phenol. Then we'll see 3 bromo, 5 chloro, 6 methyl, and then the whole body is phenol. Okay, guys, so we finished all those here. Now we have to look at the carboxylic acid and ester and amides and amine. So we have four functional groups we can look at. And let me just look at them here. We said amine, amides, carboxylic acid, and esters. Well, it turns out to be carboxylic acid always acid always will end up with COOH group. This is carboxylic acid functional group, which is C double bond OH. And then we'll have whatever attachment might be here. So in order to name those, I mean, we can add more carbon if you want to wish to do that. We can. Let's add more carbon. So let's add here more carbon. We are looking at this ending, that's ending of carboxylic acid. So how we name this? Well, we number the number of the carbons. Will control even the attachment. So this is always number 1. This is always number 2, 3, 4, and 5. So 5, that's a pentane. So that's 5-pentane. Now you take the E out, you add OIC acid. So this is pentanoic acid. Pentanoic acid. If you have any attachment, whatever attachment might be here, so just the number of carbon of a carboxylic acid location will control the numbering of the whole chain. So this is called pentane. Take the E out, add oic acid, pentanoic acid. Okay, guys? The ester is coming from the reaction of carboxylic acid with alcohol. So if we look at this, let me see the esters. So esters are made of alcohol plus carboxylic acid. So if you have, this is carboxylic acid, for example, this is acetic acid. Now, if you let it react with the methanol, OH, meth, one group of methyl group, methanol. So you will see the H will be taken of the acid with the OH of the alcohol. Then you will have something looking like this: COOCH3. So this is the O here. So this will call, because you have the combination of an acid and the alcohol, so will be methyl ethanoate. So this one will be, so from the alcohol you take the methanol take the methyl, instead of methanol, methyl. And then those carbon 1 and 2, correct? Ethanoic acid, correct? Ethane, take E out, add OATE, ethanoate, methyl ethanoate. The commercial name called methyl acetate, but we call it methyl ethanoic according to ethanoic acid, because this is 1 and 2. That's ethanoic acid with the methanol. So it's this is from the alcohol, this is from the carboxylic acid, which is ethanoic acid. Ethanoic acid, oic acid will turn to be OATE, ethanoate. So that's the esters naming. So now we'll go for the amine and imides. So let's look at this. Amine and imides. First of all, the types of amines, we have three types of amine: primary, secondary, tertiary. So amine is a relative of ammonia. So this is ammonia here. This is ammonia, and then you replace the hydrogen with what? With a group, with the functional group, with organic functional group. So if I will have 1, 2, and 3. So if I replace only one hydrogen, say with one methyl, okay, then I can, this is called primary. I can replace the other one, CH3, NH, CH3. That's called secondary. Now I can replace the last one, CH3, N, CH3, and here CH3. This is tertiary. So those are three types of amines, three types of amines. Now, naming the amines, always you name whatever the alkanes they came from, and then you will end up with the amine itself. So suppose I have here the common name is the easier to name. So suppose here I will say this is methylamine. That's a common name. Methyl what? Amine. And that's not the IBC correct name. We go by the carbon here, one carbon, that's ethanamine. Ethane, take the E out, amine. This is the same thing here. You have this is ethanamine from one, correct? And you can therefore the common name will be dimethylamine, dimethyl two amines, but we can name it by one carbon is this as a methane, and then you can hook up N-methylamine. So ethane, and then N, the N is hooked to the N is a methylamine. N is means this amine here, this methyl group, sorry, this methyl group is connected to the nitrogen. And here's the same thing. Here is one of them is methane, and then NN instead of having one N, NN means 2-methyl. So this one here, let me just try to name this for you guys. Let me take this and write it in a way you can see it. So this one here, I can name it, this compound here, N, correct, CH3, CH3, CH3. So I can name it, one of them is methane, that's carbon, correct? So methane. And then do you have two methyl, N, the two metals are NN, dimethylamine, okay? Without the E, not methane, but methane without the E, methane, NN dimethylamine, okay? So dimethylamine, you have two amines there. If you, the common name will be trimethylamine. Now let's look at the amides. The amides, let's clear this one here. The imide, on the other hand, is a combination between carboxylic acid and amine. So if we have something like this, CH3, COOH plus CH3, NH2, so the H will be coming here, you get H2O out. One of the hydrogen will come and take this OH here, correct? So you get CH3, CON, CH3, correct? H plus H2, of course. So again, it's always is about this group here. This group here is called the imide group. And it goes again by the number of carbon here. So one carbon, and you have one carbon here, you have one carbon here. That's called ethanoic acid. It came from ethanoic acid. So ethane without the E, comma, N methyl. The methyl is connected to the N, and then imide. Imide. So ethane and methyl imide. So those are name of the groups. The last two things is to look at the aldehydes and ketones. Well, it turns out to be that will come later on. Aldehydes are always functional group always comes at the last. I mean at the first position. So here it is. So CH2, 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 CH2 here, sorry, CH3. So this functional group called aldehyde, and in IUPAC name called what? We ending is AL, AL, okay? So this one here, how many carbons we have? 1, 2, 3, 4, 5. So this is bentane, or again, that's always the alkanes. Take the E out, AL, bentanal. If we can name it, will be bentyl, if you want to say, or bentyl aldehyde. So this is bentyl aldehyde or pentanal. So the easiest one is, the IUPAC name is bentanal. So the group here comes first. Always the numbering here 1, always 1, 2, 3, 4, 5. That's bent. And then pentane, take the A out, add Al, pentanal. You don't have to designate one because aldehyde functional group comes always number 1. Now the ketones, on the other hand, ketones cannot be number 1 always. It's number 2, the functional group of ketone. So for example, I have CH3, CO double bond CH3. So this is 1, 2, 3. 3 carbons, correct? 3 carbons is propane, correct? Take the propane, the ENE out, add ONE instead. This is propanone. And is understood is always number 2, correct? So we can number them. Always the least number, whether left or right, is 2. 1, 2, 3, or 1, 2, 3. It's the same thing. So 2 propanone. Now suppose we want, this is the commercial name of it is acetone or propyl, the propyl ketone. So suppose we have longer chain. Suppose we have a longer chain. So suppose we are, we will extend this. So suppose we have here C2, CH3. So in this case, if you look at the whole thing, you keep this functional group, the ketone, or the keto group, or the ketone group, which is ending ONE, always give it the least numbering. The least what? The least number. The least numbering, either from left to right, it will be number 2, but from the right to left, it will be 1, 2, 3, will be 4. So 4 is a large number. So 2 is good. So then we have um, we have number 2. But how many carbons we have? Well, it turns out to be 1, 2, 3, 4, 5. This is pentane, take the E out, O-N-E, pentanone, 2-pentanol, with the carbon, the functional group, keto group, or carbonyl group is number 2, so 2-pentanol. I think this will cover all the naming of all the groups so far we will cover in this semester. And we can go and look at the last thing here, types of structures. We have molecular structure, molecular structure. This is C3H8. Then I can make out this molecular structure is a condensed one. Condensed structure. This condensed structure, it shows just the bonding between the carbons, not the hydrogen, the carbons. So carbon bonding only. So this is C3H3, so I'll say CH3, sorry. I have 3 carbons, CH2, CH3. So if you look, count the number of hydrogen, 3 and 2, 5, and 3, 8. That's correct. So this is condensed structure, so I show just only carbon-carbon single bond, or I show the double bond, but I don't show the details. So then we have a third type called expanded structure. Called what? Expanded structure. So let's take this one out. Let's look at the number 3, called expanded structure. In this, all bonding will be used or utilized. All bondings will be utilized. So CH3, C, 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 C. So all those. So H, 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 and H. So we have molecular one, just show you the whole thing condensed together in ratio between the number of hydrogen. Condensed show you the carbon-carbon single bond. And the expanded one expand the whole, showing all the bonding between carbon-carbon and carbon hydrogen. If you have oxygen, will show the same thing. Will show all the bonding between all the atoms within the molecules. I think we covered most of the stuff, and if you have any question, just please let me know. Thank you very much for listening, and I hope you have a useful knowledge of this recitation today. Thank you.